A capacitor is a device whose most important element is the gap in the middle of the device. This gap is called the dielectric, and at its most simple, it is filled with air. It is this dielectric material that determines how much charge a capacitor can store. For our purposes, we are going to discuss the electron as a charge. Other charges exist, both positive and negative, but the negative charge of an electron is the basis for electricity. The other aspect of a capacitor, the plates, concerns the build-up of electrons and the effect this has on the capacitor. The plate of the capacitor connected to the higher potential side of a circuit allows for a build-up of electrons. The dielectric prevents these electrons from crossing across the other plate and forming a current. In this way, a capacitor is the same as the thundercloud, ground, and air in a thunderstorm. The thundercloud is where the electrons build up, and the air is the dielectric preventing the electrons from discharging to the ground. The build-up of charge on one plate does something else to our capacitor. The build-up of negative charge on one plate causes the repulsion of the negatively charged electrons on the other plate of the capacitor. The removal of this negative charge leaves behind the positive charges of the nucleus of the atoms the electrons came from. As the electrons are forced onto the first plate, they build up and induce a greater positive charge on the other plate. This build-up of charge on either side of the capacitor creates a new potential difference across the capacitor. The charges build up, making a bigger and bigger potential difference between the plates, until eventually the charges overcome the resistance to the dielectric and cross the capacitor. This is the maximum charge a capacitor can store. It stores it within a maximum potential difference, and the combination of these two properties is called its capacitance. The capacitance of a device is equal to the amount of charge the device can store per unit of potential difference. The symbol for capacitance is C, and it has the unit of the farad. 1 farad is a very large capacitance, and is equal to 1 coulomb being stored in 1 volt.